Hello, hello. Cool. Can you hear me? All right, let's do this. So I'm Sylvain Rebaud, and we're going to talk about functional reactive programming with RxSwift. So the first question is, how many of you know RxSwift? Okay, there's a few. How many have used it? All right, awesome. All right, so today we're going to talk about functional reactive programming principles. We're going to talk about RxSwift building blocks. We're going to walk through an example, and there's be some final thoughts. Okay, so what is functional reactive programming exactly? Well, there's functional programming and functional reactive programming. And Swift brought it to the foreground, but at its core, functional programs have functions. And so these functions have properties. They're immutable, so they don't modify states. They create new states if needed. They're stateless, so they don't know anything about their past. A function takes an input and produces an output. And that makes them predictable because it's always going to be the same output, no matter what the same input. It means that you can reason better about your programs. And they're also very testable. There's no global state. It's easier to test. What about reactive programming? So reactive programming is about specifying what you want the program to do instead of exactly the steps how to do it. For example, take a table view cell. It has rules, and it's what their value should be. And cells automatically update when you modify a value because someone else has already done the job for those. And so a reactive programming framework does the work to make that update for you. So you specify the behavior of your code up front, and you gain derivative state instead of defining all the different states interaction of your program. So what that means is that your logic is contained in one area. You don't have any more, you don't have spaghetti code, with callback blocks and temporary properties to kind of save state for later. In reactive programming, time is the first-class citizen. So why do we want to use functional reactive programming? So the quote from Josh Abernathy says, UIs are a big, messy, mutable, stateful bags of sadness. And what that means is that you need to change state to update the UI, otherwise it would be very static. So we can't remove that. But actually, you can replace UI with apps, I think, in this code. Why is that? So here's an example. Every line of code we write is executed in reaction to an event, whether it's a application lifecycle event, network response, a UI touch, or notification. But these events come in many different forms. You have notifications, you have KVO, Grand Central Dispatch, delegate, and closure. But ultimately, what they do, they're just triggers for your code to execute some of your code. So how does functional reactive programming make it better? By defining an abstraction layer, a common interface for these events. So it does not care about the source of these events. As a result, it simplifies your program. And once you have this abstraction and this simplification, you can do some interesting stuff. For example, you can start composing them or manipulating them or transforming them and coordinate these events. So what exactly or how RxSwift does it? So almost 10 years ago, Microsoft decided to look at solving this problem. And they released in 2009 a client and server-side framework. They called that the Reactive Extensions for .NET, and also called Rx. And it was open source in 2012. And since then, it has been ported to many languages. We have RxJS, we have Rx Kotlin, Rx Scala, and RxSwift. But all these libraries, they implement the same behavior, the same APIs. And at its core, it has three building blocks: observables, operators, and schedulers. So let's talk about observables first. So I wanted to show you a little bit of an example so that you kind of grasp what it is, and then we'll go a little bit deeper. So here you have, when you start using the RxSwift framework, specifically RxCocoa, it adds some sort of extensions to every UI elements that you have. For example, here it's a UI text field, and it adds this text observable. And what that means is that every time a text is entered, it's going to print something. So we subscribe to here, and then we're going to print. So here's how it's going to look like. You see that as I'm typing, it's printing whatever the text field is sending. So what exactly they are? So observables, they emit a sequence of events to their observers. So every observable can have one or multiple observers. So in the previous example, there was only one single observer. You could have multiple ones. And what these observables do, they have a simple set of rules. They emit none, one, or more next events. And then they're terminated either by an error or a completed event. So here we have, in the first observable, we have something that completes immediately. In the second one, we have two next events, and then it errors out. And then we have the final one, which is a series of next events that never completes. So what can you use observables for? Pretty much everything. So it's a very simple model. But imagine a network request, for example. The way it's encoded is an observable, and then there's a single next event that sends the data, and then it completes. For large downloads, maybe you want to receive not all the data in one go, but just little chunks. So it would be multiple next events, and then it would complete, for example. But for user interface control, it's actually never ending. The user is tapping on the screen, and it just generates an event, so it never completes. So with these simple models, you can pretty much model anything asynchronous. And that's the beauty of it. Well, what about events? What are they exactly? They're actually anything. So that's what makes Rx, powerful. Observables is such an interface to handle asynchronous events. But the content of this event is context dependent, is context specific. So for example, in the first example, it's a UI text field. So the event conveys text, but in the case of a network response, the next event might include some JSON or something else. So it really depends on the context of usage. The way RxSwift defines it is like this. It's an enum, and you can convey the data in the next as an associated value, or the error when it's in an error. So let's talk about errors. What are they? So if you know Swift, it's going to look familiar to you. It's called railway-oriented programming. What that means is that you got these functions on the bottom here, and as soon as there's a problem or an error, it will diverge from the main path and immediately shortcut it and go straight to the end. So there's no asynchronous callback or pyramid of doom. It's just errors are handled in one spot, and we'll see how. So once you have this common concept of observables and events, you can start to apply some operations on these observables and that's called the operators. And so they're highly decoupled, and you can compose them. And their contract is they take an input, and they asynchronously provide an output without causing any sort of side effects. So here's a list of operators. There are many more, but we're gonna go through a few. So here's the same thing that we had earlier. We're taking a text, and we use orempty, which essentially transforms nil into an empty string. And then we apply a filter operation on it. So here we're going to say anything that is below 3 characters, just don't send it. So one way to better visualize operators and the effects, we use something called a marble diagram. And essentially, it's a plotted values over time. And so the filter here represents the operator that we apply to the observable, but more specifically, each value that comes out of the observable. So you can see here that we are filtering anything, the C, the CA, but the cat actually goes through. And then when we delete the last character, it doesn't send it. So let's see what it looks like. So here you can see that it's nothing gets printed until you have 4 characters. And then when it deletes, nothing gets printed when it's below 4 characters. So let's look at another example. So you have filter, but you have other concepts. Map is another one. So here we're taking the text observable, and then we are transforming it and returning the length of the string instead. So let's see the marble diagram, same concept. Every value that gets sent over the observable is transformed into a number. And that's what it looks like. So it's pretty obvious example, but you can start composing those. So by taking the text observable here, we're mapping it and we're filtering it and we subscribe it. So the important thing to note is that at each stage here, the operation returns an observable. And so when it's time to you apply a transformation, you get back that observable. And because at each step you get back an observable, you essentially have something we call the fluent API. And the fluent APIs, you can chain them, chain operators like this. You have something very, very readable. So the graph that we have, when you try to graph it, you see all the different operations. And what you can see here is that RxSwift is very good at describing unidirectional flows of data. So, but how do you cancel a subscription to an observable? What we didn't show earlier is that the subscribe actually returns an object, and this is something called a disposable. And the disposable, they have a single method called dispose. When it is called, the subscription is canceled, and any work that was performed by the observable stops. And so why is it important? Well, if you don't cancel, the observable will continue forever, and you will have a leak. So it's important to cancel your subscription to observables. But in reality, you really dispose subscriptions manually. Instead, you use something we call the dispose bag. And so the dispose bag is bound to the lifetime of the object that created it. And so here, we're saying that whenever the dispose bag is deinitialized, all the subscriptions that were added to that dispose bag will be also canceled and stopped. But you can also stop observables using operators. Okay, so we talked about the basics. Now we want to try to do a little example, a little bit more complicated. So here, what we want to do is we want to build an app that, given a certain entry, is going to make an API call to Giphy and try to download some animated GIFs, and then display them in the table view. So here we're typing cat. And I think we're going to tap dog now. Anyway, so that's what we want to do. This is for Bogdan. Bogdan likes raccoons. Okay. So how do we decompose what we want to do? So we first, by starting a text, we're going to do some filtering and some operations on it. And then eventually we're going to take that text and make an API call, get back some JSON. We're going to massage this JSON, extract URLs, and download these GIFs, and then display it on the screen. That sounds like a lot. Okay, let's see if we can do it. So first we need to get the user input. So UI search bar has the same extension that a UI text field has, which is as the user taps, it gets a text as the output. So here we want to filter any empty strings. So we want to have a string with at least one character. And here we are going to make an API call. So we don't want to make a request for every character that the user is tapping. So it would be very wasteful. So instead, what we want to do is we want to wait a little bit until the user stops typing. That's exactly what debounce does. So what debounce does is that it receives a new value, and it will wait until that timer expired. And if an input comes in before it expires, it will reset the timer and wait another. So here we're waiting half a second before sending the text to the following on the subscription, on the observable. Okay, so and then we want to make sure that we don't send the same request twice with the same query. It would be wasteful. So we have this operator, which is distinct until changed, which does that. It will cache the value, and if the same value comes in, it will just ignore that next value. So you can see, like in 2 lines of code, see how much time we saved. If you had to do it in an imperative way, we'd have to have a timer and keep track of variables to keep track of what's going on. It would be pretty difficult, and it's so much easier to comprehend. Like you can read. So now we want to make a text, an API call with a text. So what I want to show you now is how you bridge the imperative world into the Rx world. So we're going to wraps the asynchronous URL session behind an observable, so we can use it in our chain. So we create a function that takes a URL request and returns an observable of the data. The next event will be the entire data. Or sends an error if it fails. So the first thing we do is that when and only when the observable is subscribed, this closure will be invoked and passed an observer object. And the observer is something that we use to send events or send errors. So we create our URL session task. We do some check on the response, the error, make sure that we didn't get anything that we can't handle. And if we do, we're going to send a custom error on the observer. And if we're able to get the valid response, and we just forward this event with the data, and we just complete the stream or the subscription immediately. And then we start the task. Remember, this will only be executed when the observable is subscribed to. So it's okay to call it here. It will just happen afterwards. And then we have this disposable that is used for cleaning up and canceling the work. So remember earlier we talked about the disposable that gets returned from subscribe. This is this disposable. So what it does, it says that whenever you dispose, it will cancel the task and will stop it. And that's it. You brought a asynchronous task into the Rx world. Actually, this code is exactly the Rx extension for URL session that you get for free when you use the RxSwift framework. So let's use it. And what this does is that for each new query we receive, we start an asynchronous data request, and we'll get the data. But we have a problem here, right? Instead of getting the result of that query, what we're getting back is an observable with the data. So essentially what it means is that we're transforming something into an observable of observables, right? What we really want is what's inside the observable. So we want to flatten it. So there's an operator for this, flat map. So what this does is that starting from the source observable at the top, it takes the observable returned by search and will flatten the result on the outer observable. So instead of getting an observable of observables, you have an observable of JSON. So in other words, we just flattened the observables. And that's what you have to do. Instead of map, use flat map. But what we want to do, though, is cancel anything but the last call that we want to make. We don't want to have multiple requests in parallel, right? And for that, we have an operator. It's called flat map latest, which means if we go over the marble again, is that when the flat map latest receives another input here, which is RA, it will immediately cancel the first JSON request that is made and execute the second one. And in that case, only the result of the second one will be forwarded. So it's actually canceling all the in-flight API calls. Okay, so now we're getting back the data from the last JSON that we did. And we want to parse it a little bit. We want to extract, the remote models. And then we subscribe to it. And that's when actually the work starts. Now, every time we get a new string from the text field, we just create an array of GIF models here, and we update our table view or collection view. But let's say you have a dodgy API, and then this URL session fails. What would happen is that the entire observable would error, and then it would just end, and you would not be able to get new query working. So that's a problem. So that's how we would do it. First, because URL session shared data is an observable, we can add operators to it. And so what we want to do is we want to retry 3 times before giving up. And when that happens, we want to catch the error, and we want to return empty. So the flat map latest will flatten the observable. And since the observable doesn't contain any values, it will just complete. And we will just end here for the next text that would come in. Again, this is in 2 lines of code. We created a timer that repeats 3 times. They will retry the last operation and then catch the error right there. But what if the network doesn't fail, but the model is not correct? How do we handle this error? Well, like we said earlier, it's right there at the bottom, right before the subscribe. We can catch the error, and instead we can say, we'll return an empty array, and that's it. So now that our observable is connected and is doing some work, we started to notice that our collection view is very slow when we're scrolling. And that's because we're making these API calls on the main thread. And that happens because an observable, the work of an observable is started on the same thread that the subscribe is being called on. So if we execute this code on the main thread, the work starting from the top will be executed on the main thread, including making the API call. So what we want to do actually is we want to do something. And what we want to do here is using something called schedulers. So schedulers in Rx world is the equivalent of a dispatch queue. That let you simplify on which queue you want the work to actually be done or performed. And like observables, they have an abstraction layer, so you can have different schedulers depending on what you need. Once you pick the right scheduler, you use two different methods. You use the observe on or the subscribe on. Most of the time, you're going to be using the observe on. The subscribe on describe when the subscription starts, where is the content of that observable executed. The observe on is rather where the events are received. So if you look at the chain here, the observe on will affect what's below the observe on. So here, what we want to do here, as soon as we get the text, we want to hop onto a background thread or background scheduler, concurrent dispatch queue, which will execute the rest of the chain onto that background queue. And then similarly, when we want to update the UI in the collection view, we want to hop back on the main thread. And that's what we do here by doing an observe on the main scheduler instance. Everything that will be delivered to the subscribe will be on the main thread. Another thing that would be nice, it would be nice if we can show some network activity when we were making an API call. And so it's very easy to do. That's with the operator do on next. Here, what it does is that it's a way to perform some side effects without actually affecting the signal. So here, every time there's a query that comes in before we make the API call, we're gonna update the activity indicator. Since we're on the main thread, it's fine. And then here, after the main thread hop, we can just say, don't stop showing the network activity. And that's it. It's pretty beautiful and elegant, I think. You can show the flow of data, in your application in one spot. It's very readable, and there's no intermediate state. You didn't keep any variable or flags. It's just in one spot. Want to see it again? Okay, let's have some final thoughts. So first, I want to give you a little bit of some advice. If you're going to start Rx, experiment Rx using a playground. It's a lot easier than having a full app that you have to compile every time. Go to rxmarbles.com. It's a interactive website where you can play with operators and values and see what happens. In general, it's better to break your long chain into smaller observables that you can reason about a little bit better, and use the Rx debug operators. Some more advice. Using lazy vars and returning observables in the lazy var is dangerous. You can create retain cycles, so be careful with those. You want to prefer to use weak over unknown. There's some really strange issues that we've encountered when using weak because of the way schedulers work. The object that owns the subscription can go away, and then the event can still be fired depending on what you do. Prefer capturing variables over self always. We will remove your retain cycles. And avoid side effects during disposal. So when you dispose and you have some events that happen, it's also not very good. You never know which thread is gonna be executed on. So what are the pros of RxSwift? In my experience, Rx reduces about 50% of the code compared to imperative code, and less code means less bugs, so it's always a good thing. It's more maintainable, so when you have your product owner coming and wanting to change the timings of things or the behavior. It's really trivial when the code is localized in one place. You don't have to dig around. It's more readable. As programmers, we spend more time reading code than writing it. I would say probably 90% of our time is reading code. So being more readable is means we understand code faster and we can write code faster. Multi-threading is hard, and it's easy to mess it up. And Rx kind of helps you eliminate a lot of race conditions. So that's a good thing. And I think also that by learning it, it makes you a better programmer, even if you're not using it, which is new skills. What are the cons? Debugging an issue involves using a lot of logs, and sometimes you end up with the long stack traces deep into the Rx framework, something that happens whenever you use a third-party framework, but it gets some time to get used to. It has a steep learning curve, but once you get there, everything starts looking like an observable. Here are some resources. First of all, RxSwift, that's where it is. Reactivex.io is the umbrella website that describes what Rx is in different languages. RxSwift community is a GitHub repository with some interesting extensions that were added by the community. Go to Slack. It's a very great Slack channel with a lot of, you can get a lot of help, a lot of good guys there. And then I put at the last the repository for the demo that we just did together. And that's all I have.